Welcome, geologists, to tsunamis. Tsunami is a Japanese term that means harbor wave. It is completely different from a tidal wave. So from this day forward, I don't want to hear you saying tidal wave unless you're talking about waves that are generated from the pull of the earth and the moon. The moon would basically have to be right on us to produce large waves, and even then it wouldn't be pulling from the bottom of the ocean all the way to the surface like a tsunami does. Tsunamis are usually a series of waves, not just one wave, that actually hit a region. That's really important to note because there's a period of time between each wave, and you're going to see why in just a minute. So there are a number of ways that we can get an earthquake to occur. Earthquakes are number one reason, but number two would probably be a landslide underwater, a volcanic eruption that may create something like a caldera, and then of course a meteorite that might strike in the ocean or a lake. So tsunamis are dangerous. To us, they don't seem like they happen very often, but when you look at geologic history, they would occur frequently. But even though they're not our most common natural disaster right now, we need to plan for them so we can reduce and minimize the potential for loss of human life. So when you have an earthquake underwater and it's at the ocean bed at a subduction zone like this, typically the continental plate is being buckled under as the ocean plate's dragging it down. And when that happens every so often, one of the plates catastrophically lets go and begins to flop. And when that happens, it lifts the ocean bed upwards and the water with it. So you must understand that a tsunami deals with a profile from the base of the ocean floor all the way up to the surface, unlike a wind-generated wave, which only deals with like the top 10 or so feet of water. So here's a situation. See if you can figure out what type of fault this was. Footwall, head wall moved down. So it's a normal fault. We had some kind of tension. And it displaced water from the bottom of the ocean floor all the way to the ocean surface. Notice that it's almost indetectable, the wave height, when you're looking at this portion right in here. But as the seabed shallows, look at what happens, especially around 900 meters or so. You begin to notice that the tsunami gets a little larger. As we get into 20 meters or 60 feet or 100 feet of water, notice that the wave height gets substantially taller. Now let's evaluate speed, because you're looking at jetliner speeds out here in the deep ocean. As we approach a shallower continental shelf, it begins to slow down. The key is the front of the wave slows down much sooner than the way in the back does. So you could have these large gigantic wavelengths here, which are literally 20 or plus so miles wide, and then they start to stack up closer to shore, and these wavelengths have a period of time between them. Let's look at a regular wind-generated wave. Notice their wave height is about 10 feet, their wave width is a key factor, only 300 feet, and their speed is 10 to 20 miles an hour. Let's put that side by side with the tsunami wave in the deep ocean. I first want you to look at the wave height of the tsunami, how variable it is. It's much smaller than the wave height of a wind-generated wave. Subsequently, it's much different in all three categories, actually. The wave length is one of the most important concepts because you're looking at something that's 316 and 18. For tsunami, all three categories are different. You're looking at wave height that's really short, wave length that's exceptionally long. If you take a mile, and a mile's just shy of 6,000 feet, let's put 6,000 into 316. Just for fun, I'm going to get my little calculator out, and let's just see what that looks like. Just an estimate, and I'm going to make round numbers here to make it easy. You're looking at over 52 miles between waves that happen out in the deep ocean for a tsunami. So that's going to change as it approaches shore and you get a shallower continental shelf. And take a look at those speeds, jetliner speeds, between 450 miles an hour to 650 miles an hour. So what happens is the front of the wave that's closer to the shoreline as it approaches a shallow continental shelf begins to have friction and slows down and grows in height. But back end still coming at jetliner speeds and begins to squash up with that wave, making it profile go up very quickly. This is extremely dangerous because the front end is still moving pretty fast, up to 200 miles an hour. This is where the tsunami becomes a wall of disaster, because remember, you're still looking at the water base from the bottom of the ocean floor all the way to the surface, so it's moving as one wall of water that could be several miles wide. This would be several miles wide right here, and we may have a gap of 10 or 15 miles in between this and the next wave, so it could be another 5, 10, 15, 20 minutes before the next wave ever hits. So let's talk about the Sumatran tsunami. This was one that happened in 2004, and you need to kind of put yourself in the place of what was going on that day. It was the day after Christmas. Think about what happens the day after Christmas, just right here in your own home area. People are going back to work, going back for the after Christmas sales. Business was usual, and at 7:58 a.m. local time, an earthquake struck that really was incredible between the Burma Plate and the India Plate. The Burma Plate is a small oceanic plate very similar to our Juan de Fuca Plate, and then there's a correlation here I'm trying to make between these plates or these situations that generated these tsunamis, so you realize at what risk we have on our west coast. What risk we have on our west coast. The earthquake measured a 9.1 after all the information was gathered over the next 48 hours or so. And so initially it was a 9.0 and upgraded. The focus was very shallow. See if this sounds familiar from your earthquake lesson, at 18.6 miles below mean sea level. The epicenter was right here. So you have to imagine that the tsunamis actually hit all throughout this region and over here in Africa, which you're not seeing. What were some of the facts about the Sumatran tsunami? It ruptured along a 750-mile transform fault area. It was a mega thrust earthquake where it had vertical and lateral movement. And literally the 50 foot was about this way and vertically. So the earthquake was what's stunning, lasted up to about 10 minutes depending on where you are. So if you don't mind, set your cell phones for a timer right now. Just take a minute to do that, and I want you to set it for 10 minutes. Forget that you even have it going, and then when it goes off, I want you to be alarmed at how long a stretch of period of time it's been into this lecture that occurred. So this is a devastating event because this long rupture zone is going to be like a domino effect with this humongous amount of energy that's cascading down this entire rupture zone at such a rare, great magnitude. This earthquake caused the Earth to wobble on its axis by 2.5 centimeters and shortened our day by literally 2.68 microseconds. We had no warning system in the Indian Ocean at that time. That has subsequently changed, but that doesn't change the fact that hundreds of thousands of people lost their lives that day. An interesting fact was a number of animals took shelter that could. Elephants, for example, that were able to move freely, ran for higher cover because they could hear and sense the vibrations of the ground, and they ran because they knew something was wrong. So I'm going to encourage you, if you've got an animal in a natural disaster that starts to do something funny, you should probably watch because they may actually know what they're doing. We got hit by an earthquake in Hurricane Alicia, and a tree came through our house in the area where my cat normally sleeps, and the cat had moved 3 days earlier to the safest part of the house. I think our cat knew what she was doing. Other facts you need to be aware of: coral reefs and mangrove swamps. If you don't know what a mangrove swamp is, I want you to Google that after this lecture. That might be something worth knowing for your test. But these had been impaired primarily from human influence, and they act as barriers and roots to anchor down sediments along coastlines. So if you had minimized those existence of coral reefs and mangrove swamps, you ran a higher risk of having a much more devastating impact to the shallower continental shelf areas hit by the tsunami. The environmental impacts are so great, I can't even begin to outline the disaster that we're facing here. Think about the wall of salt water that came in, and not just one wave, a series of waves, depending on where you were, that depended on the number of waves that came in. That salt's going to contaminate surface water, the ground, building structures. If your drinking water is contaminated, now you have to find another freshwater resource that hasn't been contaminated by the massive inundation of water that's done more than just contaminate with salt. You need to think. This is incredible. Every wastewater treatment plant, every septic tank, every porta potty, every hazardous waste site, every landfill or trash container is out and about. Every petroleum storage tank has been knocked over. All of this stuff is freely floating in water. Every medical piece of waste that's out there is now available in water. Your head's like, ew, that's so gross. Well, it should be, because that's what these people were having to live with, and were being tossed around in these very toxic, dirty water conditions. There was severe damage to rocks and rock formations and even fault zones. So this was an environmental impact that will have decades of understanding how this really impacted the region. So I want you to think about where you would hypothesize where most of the people would die in this particular event. Did they all die in Sumatra? Would you have thought some would have died in Thailand or Malaysia, India, Sri Lanka? What about the east coast of Africa? So I want you to just make a short hypothesis, write it out right now, where you think the greatest death besides Sumatra was of people and why. Why don't you go get a map out before we go any further? And I want you to think about that and predict where you think the worst impact would be and why. So let's take a look and see if you're right after you've gotten that done. Please push pause while you are doing your hypothesis. All right, so if you listed as Sumatra as the #1 place, you were right. What was #2 on your list? Was it India? Was it Sri Lanka? Or was it Thailand or Malaysia? Interestingly enough, Sri Lanka was the #2 hit place. A lot of people died along the coast because there were some trains that were traveling in this particular area that they got derailed and knocked off. India came in #2 with over 15,000 deaths. Look at Thailand with almost 10,000, and then you come over here to Malaysia. Indonesia acted as a speed bump and slowed down and reduced the number of deaths that Malaysia got. Well, let's come down here, and the Maldives stood no chance. They were hit as an island, but I want you to look at this east coast here of Alaska, and let's contemplate why that number is so low of deaths. And it had to do with the Pacific warning system for tsunamis. That Pacific warning system, those people got busy getting on the phone, calling anybody who would listen and said, hey, we have scientific data that shows a tsunami's coming your way, but we have no idea how long it's going to take to get there because we don't have any historic data of the seafloor and the speed of tsunamis that have traveled historically through your area. Obviously, some of the countries listened. You have to wonder about Somalia. Was it that the waves were just too great and too many people were in the wrong place at the right time, or did they not issue the same warnings? Nevertheless, there was no warning system in 2004 when this occurred. So here's some tsunami destruction in Thailand at a resort that occurred, and you can watch the water come in. These were still shots taken by a bystander that looked at this area. Now, I can't tell you, let's go back one. I want you to see this guy right here. I can't tell you if this guy's going to live or not. We don't know the answer to that. I would suspect probably yes, because it looks like he's actually in pretty shallow water at that point, and these people are watching him pass by. But the message here is how fast the water came in and how it just left a trail of devastation everywhere it went. Keep in mind there was more than one wave, so when these people go back out like they were for cleanup, that's some seriously bad news if another one's coming in shortly thereafter. So the destruction was just unfathomable when you look at all of this debris and the contamination that must have occurred. Here's Thailand in harbor. I mean, this is way inside the harbor in the city, and look at all these. The water took the path of least resistance and just started flooding out everything and picked up anything in its pathway. While these images may be the hardest to look at, it's the realities of a natural disaster like this. I need you to think about what happened to their freshwater supply, what happened to their electricity. All of that's gone. So what they have is backup generators and a bunch of deceased corpses that they're going to have nowhere to store what they normally would in refrigerated units. People that are just have lost everything, their families, their houses, their money, all of that. This is just an incredibly difficult situation. And this is just the beginning of their cleanup and their recovery after such a horrible natural disaster. So this is the peninsula where the hardest hit area was of Banda Island satellite imagery before the tsunami. Let's see what it looks like after the tsunami. It's breathtaking, isn't it? Let's put them side by side and let you ponder how much land and property was actually destroyed. So if there were definitely people on this land, this was the hardest hit area, they didn't stand a chance. But there was a chance for Sri Lanka. There was a chance for the east coast of Africa. There was a chance for India, which was the learning lesson that came out of this natural disaster. Was even though people in the general scientific community had not considered that the high risk, this is a substantially high risk area because of the subduction zones in the region. That moves me to the 2011 Japan tsunami. This happened at the peak of the workday on March the 11th, 2011. I can tell you where I was. I was on my honeymoon on a cruise, and we had been at the midnight buffet heading back to our cabin, and we witnessed this happen in real time. And I remember staying up most of the night watching this, just awestruck in such a horrible way of what was going on with these people. This occurred at a subduction zone with a little bitty microplate where the Pacific plate and North American plate are having a relationship, and it's called the Akash microplate. So very similar in shape and size to the Burma plate and, oh, I might add, the Juan de Fuca plate. So see a little trend going on here? This was a fairly shallow focus, 20 miles, just like the others, and it lasted about 5 minutes, so half as long as what we saw in Sumatra. It initially registered a 7.9 and was upgraded to a 9.0. So once all the data comes in from the seismograph stations around the world, these things can get upgraded. Interesting facts about this tsunami. Parts of the northeastern Japan moved literally 8 feet closer to North America, and some of the Pacific plate actually laterally moved in a westward fashion up to 130 feet. That's a phenomenal amount of energy released at that fault zone. So we shortened the day a little bit less than we did with the Sumatran by 1.8 microseconds, and we had tsunamis that reached waves of 133 feet. You don't need reminding what that looked like because you saw these images. This is some of the images that I remember vividly happening live as we watched them on our cruise. Keep in mind, there was no warning system for the Sumatran tsunami, but there was plenty of warning system for the Pacific one that happened in Japan. The couple of surprises in the Japan earthquake was the tsunami hitting the nuclear plant, obviously, but the system went into effect and did save lives. However, there were people, just like there was in Banda Island or Banda Aceh, that there were people that you saw on the peninsula, like you did in Sumatra, that didn't stand a chance. There was no way they were going to beat this thing. So even the best of warning systems can't save all lives, but they can certainly save a lot of lives. And that's the spirit and intent of understanding why we have a tsunami system. The Pacific Tsunami Warning Center was one of the heroes of the 2004 Sumatran tsunami because they were the ones that helped save lives on the east coast of Africa. Had they been able to get warnings out faster, they could have probably saved lives in Sri Lanka and India. When their pagers started going off, they started analyzing data and thought it was much smaller than what it ended up being. Within a few hours, they realized they were dealing with a much higher magnitude and damaging tsunami earthquake. Okay, so we're looking at the DART system too, and I'm actually going to trigger an earthquake and let you see what this thing looks like, because it's actually anchored to the ocean floor, and you have a seismograph station that sends out signals for the movement of the water, not just the seismic event, but it's sending out wave movement and speed and height of that back to this, which relays a message to a satellite and then back to stations around the world. This particular system is extremely important to us because it's helped us actually revolutionize how we're dealing with tsunamis around the world when we get these really catastrophic earthquakes. This is what the buoys actually look like. You just saw the animation, and remember, they're hooked into the ground, and then you've got this particular system that measures the ground shaking, which would be the seismograph station, plus the movement of water to understand intensity of the water movement, which gets in turn sent to the mooring system, relay system to the satellite. It's a very complex system, very expensive. So you might wonder, why didn't they have one in the Indian Ocean basin? Not only do these cost hundreds of thousands up to millions of dollars to deploy and to maintain, you have to have a working relationship between countries of how you're going to issue these tsunami warnings. Regardless of wherever you may be, if you travel to an area that has warning signs like this, you need to take heed that tsunamis are real. We are in the same place that Sumatra and Japan were on their day before their events, in that very location of Oregon, Washington State, and Northern California, where the subduction zone of Juan de Fuca exists. So let's hope we don't see another tsunami in our lifetime, but if we do, you know the areas that they would likely happen, and it's at major subduction zones around the globe. I'll see you at the next lecture. Bye.